All right, so opposite side is equivalent to, or visually is looking like it's our x. Adjacent side, excuse me. Opposite side is our y. And then our hypotenuse can also be considered r. So given that information, I want you to think about what the ratios are for each of the different trig functions now. So for sine, don't think opposite and hypotenuse. Tell me what the new letters would be using x's and y's and r's. What would the ratio for sine be? Jaden, what do you think? Y over r. So for the sine ratio, we do y over r. Okay. What about cosine? Chris, what do you think? Tell me what it is using SOHCAHTOA.
It would be hypotenuse, or adjacent over hypotenuse.
Okay, so now looking at this triangle, what's adjacent? What are we calling that side? X, okay, and the hypotenuse we're calling R. So cosine, you need to memorize as the ratio is x over r. What about tangent for the last one there? Armand, what do you think? It would be y over x. So yes, this is what you've got to get memorized now. The sine ratio, besides thinking of it as opposite over hypotenuse, we're going to extend this and we're going to put this on a coordinate plane. You need to be thinking of it as y distance over r. For cosine, x over r, and for tangent, y over x. So those are ratios that you are going to need to get memorized. I'm going to show you a few different examples of how these are used, okay? So that's what we're going to look at. The beauty of memorizing the reciprocals is that you can always go back to that reciprocal, okay? In other words, for me, what I have memorized is the fact that I know cosecant is the reciprocal of sine. If I know what the sine ratio is, then all I have to do for the cosecant is flip it. If you want to take the time to memorize the cosecant as r over y, you can do that. But in my opinion, it's easier just to remember I'm going to flip what I know the sine value is. For secant, it means I'm going to flip what I know the cosine is. And for cotangent, I'm going to flip what I know the tangent is. So that's how I like to memorize that. And I think that that tends to be less that you have to just kind of commit to memory there, Max.
I understand when you use like sine and like the inverse of sine, but when you use like cosecant, what would it look like? Where you like use that?
A lot of what you're gonna see here today, where we are looking at just specific values. So if you're seeing something about a cosecant, we're gonna connect that back to sine, typically. But yeah, you might be asked, are there any here in this? Yeah, you're asked, what is the cosecant at 0 degrees?
But like on a,
So there's gonna be,
on a triangle, how do we know when to use it?
you'll be asked for it.
Okay.
Yeah. All right. This is kind of a special case that we're going to look at in this particular situation because we're looking at quadrantal angles. So if we had coordinate points, then we would draw our triangle and we would be able to label our sides and we could solve a particular problem. If we are given quadrantal angles, basically what happens is that the triangle collapses, right? And so we're just given points right on our x and y axis. So you've got to remember first that our 0 and our 360 is here, our 90 is here, our 180 is here, our 270 is here, right? Okay. I think most of you know that. I'm going to write that in just to kind of refresh your memory on that part of it, right? For quadrantal angles, just pick a number, any number. Aiden, what's your favorite number? 4. Okay. If you want to use your favorite number instead of 4, then go for it. Your numbers are going to be a little bit different, but overall, your answers are going to be exactly the same, regardless of what you choose. We're going to move out a distance of 4 in each direction, so I want you to think about the fact that right here on that axis of 0 degrees and 360, it means we would be going out 4, 0. Up here, we would be at 0, 4. Over here, we're at negative 4, 0. And then down here, we're at 0, negative 4, right? What would R be equal to? What is the distance from the origin out to any point on this graph? 4. So R is 4. By the way, R always must be a positive value. It's a distance. So R will always be positive. So keep that in the back of your mind, okay?
If we ever get a negative number, would it just be like absolute value?
For R, if you get a negative answer, it means you've done something wrong because it should be positive. I'm trying to think of situations where you would like have to choose or decide. Yeah, I off the top of my head, I'm not thinking of any.
Okay.
But if something comes up, remind me of that so we can kind of talk about it. But I don't think that'll happen. All right.
Are the hypotenuse?
I'm sorry?
Are the hypotenuse?
R is like the hypotenuse, but in this case, our triangle basically is collapsing on itself because we don't have enough to actually create a triangle. So that's why we need our X's and Y's and R's in order to solve all of these problems over here. So these are all special cases. The answers that we get are going to be very special also. They are going to, you're going to see a pattern here with all of these numbers, all of the values that we get as answers, okay? All right, the sign ratio. What's the sign ratio, Jaden? Y over R. So if we go to 90 degrees, that's this point here, right? And we do Y, the Y value over R, then we've got 4 over 4, which is just equal to 1. So the sine of 90 degrees is equal to 1. Always will be. Whether you choose to use a different number that you, over here, like I said, if you wanted to use your favorite number, my favorite number is 7 instead of 4. Go for it. Whatever. All right, cosine of 180 degrees. Cosine, what's the ratio for that? Sebastian, what's the ratio for cosine?
What do you mean?
Using X's and Y's and R's, what's the ratio? X over R. So we're going to go X over R. We're going to move to where 180 degrees is. That's here. And we're going to look at the X coordinate, which is negative 4, over R, which is 4. So we get negative 1.
Can I use the restroom real quick?
Wait till we have gone through this, please. All right. This is to give us practice with these ratios, to try to help us work with memorizing these ratios, but I'm also because ultimately at the end here, I want you to see a pattern that develops with our answers, okay? So tangent of 270, the tangent ratio first. Campbell, what's the tangent ratio? Y over X. Tangent is Y over X. So we're going to go to 270. We're going to look at Y over X. So we get negative 4 over 0. Guys, what's that equal to? Undefined. There you go. I will warn you, quite a few of these are undefined. The answers. Cosecant of 0 degrees. So for cosecant, we know we're thinking reciprocal of what, Davis?
R over Y?
Okay, because it's reciprocal of, okay, it's reciprocal of sine. So yeah, we're going to want to flip it. So we're going to do R over Y. So at 0 degrees, R is 4. Our Y value is 0. So we get undefined again. All right, secant of 90 degrees. Secant ratio, we got to be thinking reciprocal of what trig function, Grayson?
Would be R over X.
Okay, because it's reciprocal of,
Sine.
I'm sorry?
Cosine.
Cosine, there you go. Secant is reciprocal of cosine. Cosine is X over R, so we're going to flip it and do R over X. Okay, so at 90 degrees, Grayson, what are the numbers going to be for R and X?
4 over 4.
At 90 degrees, so this, what's the X? Okay, so we get 4 over 0 again, we just get undefined again. All right, cotangent of 180 degrees. Chloe, what are we going to do for the ratio there for cotangent? Okay, x over y at 180 degrees, what do we get?
Negative 4 over 0.
Okay, so we're undefined again. All right. Onward, cosine of 90 degrees. Cosine, Leo, what's the ratio? Careful for cosine.
Sorry, that's x over r.
X over r, there we go. So cosine is x over r. We're at 90 degrees and we want to do x over r. What do we get for those numbers?
0 over.
For 90 is 0 over 4.
Which is equal to 0. Good, excellent. Okay, next one, tangent. Avery, what's the ratio for tangent? X's and Y's and R's. Y over X, there you go. So we're going to think Y over X at 180 degrees. So what do we get, Avery? 0 over negative 4, which, yes, gives us 0. And last one, cosine of 360 degrees. The cosine ratio, Chatham?
X over r.
X over r. At 360, if we look at the x, what do we get?
4 over 4.
So 4 over 4, which is equal to 1. Beautiful. All right. Thank you for waiting. Go quickly. The intention was to give you a little bit of practice with trying to get those memorized. I want you to notice the types of answers that we received, that we got for all of these quadrantal angles. And it will be the case for any quadrantal angle. If you're taking a sine or a cosine or a tangent, it doesn't matter whether you use 4 as your r or 28 or 50,000. If you write out that ratio and you solve these problems, you're always going to get either a 0 or a 1 or a negative 1 or an undefined. Okay? All right. Comments, questions, thoughts on that? Okay. So now let's extend this to actual coordinate points in the coordinate plane. I want you thinking about the fact then we have this point, so we know this is our x, this is our y. We're going to have to figure out what r is equal to. That's easy enough. We can use Pythagorean theorem. But guys, that's a triple. So what should r be equal to?
13.
Not 13. 15, because it's a 3, 4, 5. Everything's just getting multiplied by 3. Okay. So we're going to do a similar process here. So the sine of the angle, we don't even know what the angle is. It doesn't matter. The sine, what's the ratio going to be, Ryan?
Y over r.
Y over r. And so we get 12 over 15. Yes, we want to simplify that if we can. So 4 over 5.
Why are we using sine? Are we doing all of them?
Yep, we're going to do all 6 trig functions. The ratios for all 6. Okay, for cosine, Davis, what's the ratio?
X over R.
X over r. And if we do x over r, then we've got negative 9 over 15. We simplify that, we get negative 3 over 5. And tangent, Amira, what's the ratio?
Y over x.
Okay, good, y over x. And if we do y over x, we're going to have 12 over negative 9. We reduce those fractions, we get 4 over negative 3. So now here's the beautiful thing. We've just found those 3 trig ratios. Now we also need to state the other 3. They are not. We just got to flip that for our cosecant. We've got to flip this, and then we've got to flip this. So negative 3/4. Does it matter if I put the negative in front of the 3 or the 5 on that secant value? No. Okay, good. I wanted to make sure you guys realize as long as the overall value is negative, it means, right?
Right.
Okay. That's a pretty simple one because of the 3, 4, 5, the nice pretty triple. This next one is not so pretty because it's not a triple. So we've got to do a little bit of math here. So 16 plus 49 is going to give us r squared. So r is the square root of 65. All right. So we've got So we're going to find our sine, cosine, and tangent, and then to get the other 3, we're just going to flip our answers.
How did you do it?
So
You squaring both.
I'm doing
Pythagorean
Pythagorean theorem, basically. I'm squaring x squared plus y squared equals r squared. Okay, so square the 4, you get 16, square the negative 7, you get 49.
Like you run through all the triple. and
Yeah, if it's not a triple, then you're going to have to find r, you're going to have to use Pythagorean theorem. Yep. Okay. For sine of theta, Aiden, what's the ratio? Y over r. So we are doing negative 7 over root 65. Yes, that has to get rationalized. So negative 7 root 65 over 65. It is, but it's not that bad. Okay, that was sine. For cosine, Max, what's the ratio?
The cosine?
Yeah.
It's x over r.
X over r, good. So that means we have 4 over root 65. When we rationalize that, we get 4 root 65 over 65. And then last one, tangent's easier. Alicia, what would you get? What's the tangent ratio?
Y over x.
Yep.
Negative 7 over 4.
So yeah, negative 7 over 4. Okay, so that's for sine, cosine, and tangent. Now to do the other 3. Let's see here. We know we're going to do the cosecant and the secant and then the cotangent, right? We're just flipping though. Now, here's where you do want to watch. I want to flip that and that. I do not want to flip what I got when I've rationalized my denominator. If you try to flip that, then you're going to have to rationalize again and you're multiplying and making the numbers much bigger. Just flip this. Negative root 65 over 7. Root 65 over 4. And negative 4 over 7. Okay? So flip what is easiest to flip. In other words. All right, we are not going to do all of these, but we do need to review and practice a little bit with the calculator. Guys, this is just saying for those first 2, you are truly just plugging in exactly as it looks like. For these last 2, don't just do these. Do 1 and 2 on top, 3 and 4 on the bottom. If you're finding an angle measure, what are you plugging? How are you plugging in? Right row.
Oh, it's inverse, right? So it's
Inverse
negative.
trig function. I heard somebody say it, but they didn't sound very confident
What?
that they were saying that. So, yes, remember? Inverse trig function. So this means you would do inverse cotangent of 4.6, inverse cosine of that decimal. So plug in, find those answers. We'll go over those in just a second. Okay? All right, what do we get here? Grayson, what'd you get for number 1?
I got 0.7569.
Okay, we're gonna go a little bit farther. Sebastian, what'd you get for number 2?
Negative 0, well, I rounded, I didn't know we were doing that, but negative 0.41.
Okay, I'm gonna take these out a little bit farther.
It's a negative 0.4067.
Okay, all right, for number 3, Chris. So remember, when you're finding angle measure, you're going to want to say theta is equal to. That should be a way to kind of remind you you're giving an angle measure. You need degrees. What'd you get for that, Chris?
I don't think it's right, but 12.42.
You are really close. It should be 12.2648. All right, Braden, what'd you get for the last one? I want to look at what you plugged in there, Chris, in just a second. Braden, what'd you get for number 4?
I mean, I got it. 0.99934.
That's what I got too.
Are you in
It's
radians
49.
or degrees?
49.096.
0.9993469393972 is my. This crazy wacky schedule I took
Why
on.
can't we just go back to the
Well, and like, it's going to be really weird. I hadn't noticed this, but Miss Cook noticed and sent an email. When we get back from winter break, I think because that Monday was going to be, I think that's a hurricane makeup day or something. That Monday after, when we get back that week, we're actually going to be doing an HFDGH. So we're actually going to have 4 days that week. 2 short ones, 2 long ones. All right. Reference angles. That's the next part of what we've got to talk about. I can tell you what this says, but it helps and it's important to be able to see this. So I'm gonna show you some examples after we read this. Reference angles are the positive acute angle, always must be acute, made by the terminal side of an angle and the x-axis. Guys, always the x-axis, always, always, always the x-axis, never the y-axis. So I need you to notice something. In this little visual to kind of help you with what you're going to do in terms of computation and figuring stuff out, if you notice, there are 180s and 360s there, never a 90 or a 270. Okay? Always with respect to the x-axis. I want you to see visually what this is really talking about. So let me show you. If you are given an angle, any angle, every angle I should say, has a reference angle also. Okay? Enough. Every angle has a reference angle. So if we're drawing 285 degrees, we're going to rotate around to about right here. We're rotating around to 270 and then a little bit more here. Okay? So that's what the angle for 285 degrees looks like. The reference angle for that 285 degree angle is actually this right here. Read what it said up here again. Reference angles are the positive acute angle made by the terminal side, that's your terminal side, and the x-axis. So this angle would be the reference angle for a 285 degree angle. The way we figure out what that is, if you notice, we ended in quadrant 4. So we're going to do 360 minus this 285. So the reference angle
75 degrees.
is 75 degrees.
What if it's like -5? Like the original number.
Then the reference angle would be 5 degrees.
Oh, that's such a cheeky way of doing it. What about?
Angle would be, the reference angle would be 5 degrees.
So it's just the opposite.
So in that case, just the opposite. If it were greater than 90 and negative, if it were like a negative 100, then we'd have to deal with that a little bit differently. Okay, let's look at a couple more examples just so you can visually see what this is, and then we'll talk a little bit more about what this is trying to help you with and some other things here. So, all right, this is saying we're going to 180, we're going a little bit farther than that. So that's what a 194 degree angle looks like, right? So the reference angle is the angle that we create from the terminal side and the x-axis. So it's this angle right here. Okay, so notice, if we're in quadrant 3 in this case, look up at the visual up there, we're gonna do angle minus 180 to figure out what the, so we're gonna do 194 minus 180. So the reference angle is 14 degrees.
Oh, so it's just.
Think about what that's really telling us, or what that's saying is above or below 180 or 360 at the x-axis, how much more or how much farther do we have to go to get to 180, or how much beyond 180 are we going, or how much more do we have to go to get to 360? That's kind of the thought process.
So it's how much we have to the closest
X-axis.
horizontal line. or
Correct.
x-axis.
Yes, exactly. So that's why, if you notice, Campbell, here on the left-hand side, we've got stuff with respect to 180 because it's the closest over here. Over here, we're talking about either the angle or we're talking 360,
What if it's right in the middle?
right?
Then it's 90.
If it's a quadrantal angle, then those are kind of special
So the reason why
cases.
we reference 285 and 360 is because it's closer to 285 than 180.
Correct. Yes.
So if it was like 180, then there is no reference.
It was just 180. All right, 120 degrees. So this is an angle in quadrant 2, right? So here's my terminal side. This is how we get to the x-axis. So that is the distance that we are looking for. That is our reference angle. So that means we are doing 180 minus 120 and we get 60 degrees.
Do you never go backwards?
Well, we kind of went backwards here because we were beyond 180 and we subtracted to see how much beyond 180 we were going, basically. Is that what you mean?
Yeah.
Okay. All right, we got to deal with a couple things here. Yeah, that's not good that you all are doing that. I know it's a pain in the neck to have to get up, and that's why I try to limit you guys going to the bathroom, because I get it, it's a pain in the neck for you guys to have to get up, but for safety reasons, we have to have that locked too. All right, if we have an angle measure, this chart only works, this visual only works for angle values that are between 0 and 360. So if we have an angle measure that is more than or less than that, we've got to think coterminal angles. So that's what we would do if we were looking at something that's like negative 190. We would need to think coterminal angles. Okay? So in this particular case, we're greater than 360. So coterminal angles tells us we need to subtract 360 first and figure out what that angle measure really is, what the coterminal angle is. 330. So then we can draw that to help us kind of visualize this, right? And so this is saying, here's the angle that is the reference angle that we need to find or consider. So we're in quadrant 4, so we're going to do 360 minus 330. So we get that this is a 30-degree reference angle. Okay?
What if the original is like 20? Then is there no reference? If there wouldn't be
If you have an angle that is in quadrant 1 that is, then it's just that angle measure. And 20 would be in quadrant 1, right?
And then if it's negative, does that flip or no?
Right. The reference angle for negative 5 degrees would be 5 degrees. Good questions. I need you to think, you're going to see problems like this on your homework as well, because the other part of your homework besides that one page is some delta math stuff on reference angles. So I want to kind of show you an example of another way we use this, right? There are 45, I'm just pull in 45 because I know we're gonna talk about the special angles. We're gonna eventually make a connection between all of these angles and the unit circle. So I wanna use one of the special angles just so that you're hearing these measurements. There's a 30 degree or a 45 or a 72 degree reference angle in every quadrant. So some of the homework questions tonight they're gonna give you a reference, they're gonna give you an angle and then say, figure out what in this case, I'm giving you the example, figure out what the 45 degree reference angles are in each quadrant. So that's what we're gonna do. So obviously in quadrant 1, the 45 degree reference angle is gonna be 45. In quadrant 2, to figure out what the 45 degree reference angle would be, we'd have to do 180 minus this, because it would be here. So what is that distance? So we're doing 180 minus 45. So we find that it's 135 degrees. To find the 45 degree reference angle in quadrant 3, we're going 180 plus 45 more. So we get to 225. Okay, think about that. If you were at 225 and you subtracted 180, we would be at 45 degrees. Right? That's what that's saying. And then to figure out what our 45 degree reference angle is in quadrant 4, we do 360 minus that 45 degrees, and we get that it's 315 degrees.
Oh, yeah.
Okay. All right. I think there's a little bit more we've got to look at here. Yes. Okay. Oh, come on. We're not going to fill anything in here. All this is doing is giving you kind of the steps or the process that you have to do to figure out what your reference angles are for these. So it's just telling you, basically decide what quadrant you're in, and then use your little visual there to help you figure that out. So try these for yourself. So try these angles, find the reference angles for all of those, and we'll go over those in just a minute. Okay, we ready to check these? All right, obviously this is 83 degrees. 213 degrees, what'd you get for that? Aiden? Yes. 33 degrees, yes. Amira, what'd you get for the 270?
270?
I mean the 290.
70 degrees?
Yes, 70 degrees, good. 134 degrees, what'd you get for that, Chris?
Which one is it?
The one,
46?
46 degrees, the 200 degrees, what'd we get, Chloe?
Which one?
The next one?
Oh, 20.
20, and then the last one, Sebastian, 300? 60. Okay. Questions on those? Not too bad, right? Okay. The only reason why I have, this is exactly what we just did on the other page. 45 degree reference angles in each quadrant. This would be the 45 degree reference angle in quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? I want you to think about what the 30 degree reference angles would be in each quadrant. So in quadrant 1,
60.
it's just going to be 30 degrees. In quadrant 2, we're doing 180 minus 30. What do we get? 150. If we go 180 plus 30 more to get into quadrant 3, we get 210. And then 360 minus 30, we get 330. So those are our 30 degree reference angles. There's going to be a really special relationship we're going to talk about with respect to the unit circle when we get to that. So I'm just trying to make some connections now of what we're going to see on down the road. Last set, 60 degree angles. Obviously in quadrant 1 it's 60. 180 minus 60, what do we get? 120, good. 180 plus 60, 240. And 360 minus 60, we get 300. Okay? All right, we are not going to worry about the bottom of this page or the next page. We will get to that. So your homework is that page 26, and then also the delta math
Is it all due tonight?
that is on reference angles. It's due whenever we have class next. I don't know when that is.
Wait, this,
I cannot keep that straight, so.
isn't that